All right, so let us take few problems based on electromagnetism today. So I'll discuss this very fundamental problem, which is based on concept of LC oscillation along with the battery which is connected in the circuit. Generally, in these type of problems, when we solve LC oscillations, we don't find a battery which is connected in the circuit. So it is more of a forced oscillation because the battery is consistently forcing these oscillations. Right. So let me try to explain you what is happening here. There are these two inductors of inductance L each, and I've got a capacitance C which is in parallel. Initially, there is no current, no charge. So capacitor was uncharged and switch was open for a long time. So practically no current. Now the question is, how will the voltage on the capacitor, like what is the equation for VC as a function of time? That is a fundamental problem that he wants me to find out. So let us see how we can approach this problem. Let us try to close the circuit at t is equal to 0. And let us try to analyze this problem at general t is equal to t. So what can happen? If there is a current I driven in the circuit, this inductor is opposing it by L di by dt voltage. And there is a distribution of current, maybe I2 here and a I1 here. So this inductor is again opposing it with L di1 by dt. I1 will cross across this inductor. I2 will come here. They will add up. They will become I, go back. Fine. At this junction of time, if the charge here is Q minus Q, we understand that I2, so I should write my first equation now. I2 is responsible for rate of increase of this charge. So I should write it as dq by dt. That's fine. Secondly, I should try to write the potential drop. So if this potential drop of this EMF ideal is E, I should write E as L di by dt term is there and L di1 by dt is there, right? That is the second equation by Kirchhoff's voltage law. And one thing I can do is I can equate the potential difference of these two guys. So I know that Q upon C is basically balancing L di1 by dt. That is L di1 but dt will be equal to Q by C. These are the three fundamental equations which I can write in the problem. So very straightforward problem. Once you understand that these three fundamental equations you can write. So let us try to derive Q as function of time. We understand one thing for sure, that by conservation, like I is equal to I1 plus I2. So let us just try to differentiate it. Let's see what we are getting. I mean, di by dt term, that is di1 by dt plus di2 by dt, right? So now let's see, what can you write with the help of these four equations? Let me just focus on this last equation. Let's see what I'm going to write. I'm going to say Q by LC, that was equal to L di1 by dt. So LC I have taken. Now I want to substitute this term di1 by dt, right? di2 by dt is something which is known to me. di1 by dt I can substitute if I can just focus on this di by dt. And remember, this di by dt can be written as E minus L di1 by dt whole divided by L. So just focus on this equation a bit more carefully. What you are going to get from here is E by L minus di1 by dt is equal to di1 by dt plus di2 by dt, and that di2 by dt term is d2q by dt2, right? And now I'm saying Q by C, LC is di1 by dt, which is E by L minus T2q by dt2, right? di1 by dt and divided by 2. Now just focus on this equation, what we have written. If you can just come to this equation, q by LC was di1 by dt, and di1 by dt here was E by L minus d2q by dt2 divided by 2. Now we have a single variable which is dependent upon time. So finally, I'm thinking about q versus t equation. And if you observe this carefully, what you are trying to get from this is 2q by LC is equal to E by L minus d2q by dt2. Now it is perfectly fine. So basically, d2q by dt2 is equal to E by L minus 2q by LC. Now do one thing. Just take that constant minus 2 by LC out. You'll have q minus, we need a term E by L. So plus, I'll write EC by 2. So I'm getting that positive E by L term. Rest will cancel out. And this is d2q by dt2. Now, this can be a linear equation, second order linear differential equation. The only thing is this variable is different. So we can do one thing. You can directly say, if you take q minus CE by 2 as a new variable, let's say capital Q, still you can say the second derivative of q, like d2q by dt2, and second derivative of capital Q, d2 capital Q by dt2, that will be same. This constant derivative will become 0. So basically, this equation converts into d2 capital Q by dt2 is equal to minus omega square capital Q. Now we are ready with our solution, because omega here becomes root of 2 by LC. That is a constant for me. And this equation directly I can write the root. So let me write the root for this equation. Remember, this Q was basically Q minus C by 2. So Q minus C by 2, capital Q, can be written as some constant like equation of SHM. So I'm writing the root for that, sine omega t plus phi. So basically, omega is known to us. Now the constraints to answer for capital Q or Q, you are bothered about A and phi. But there are two things which are known to us in the problem. So if you read the problem, boundary condition. So at t is equal to 0, you know that the charge was 0 in the problem. So it is minus CE by 2 is equal to A sine phi. Not only this, at t is equal to 0, the current through that capacitor was also 0. So if we take dq by dt, it is A omega, right? This term will be 0, cos omega t plus phi, and t is equal to 0. That was A omega cos phi, and that was also equal to 0. So from these two things, I'm just writing my solution. So phi comes out as minus pi by 2, right? And this amplitude comes out as CE by 2. Once I do that, because these two, so phi and A can be written as I know that this is 0, and minus E by 2 is A sine phi. So I know phi, I know the value of A. I'll substitute them back. So what I'm getting here is, my interest was small q. So small q as function of time is capital CE by 2 plus A sine omega t plus phi. So CE by 2 sine, what was omega? Root 2 by LC into t plus phi, and phi is coming out as minus pi by 2. And his interest is not q, he was interested in q by c. So you want to write q by c, the c will cancel out. So your answer is E by 2 into 1 plus sine this minus pi by 2 is minus, sine minus cos it is cos of root of 2 by LC into t. Effectively, the answer to the question is this. This question in the problem was, I'll go to the question again. The question was, these are the two inductors. Initially, they were not having any current. there was this capacitor which was uncharged, and you connected them with a battery of EMF E. And your question was, how will the voltage on the capacitor vary with time? Now understand one thing. I have written the variation of charge as a function of time. So obviously you understand now all the things that you need in the problem are known to me. Once I know Q as function of time, Q by C was the voltage. This voltage is known, so I know LD I1 by dt. So I'll integrate, I'll find I1 also. And I1, I2 are known, so I can find out I. So in fact, any voltage, any current that he wants me to calculate, that can be written as a function of time in this LC circuit. As far as the omega is concerned for the circuit, and we know that this circuit, you know that you can write it as 1 by root L effective into C effective. And this was a thing which was known to me. I could have written it as root of L effective, C effective, and L effective. If I short the battery to find out L effective, those two L will be in parallel. So I could have written L by 2 and C effective as C. So this is also one method. In this method, I mean this trick based method, what I could have done is, I could have directly written that my omega is root of 2 by LC. Then I would have speculated a oscillatory solution. So in this method, my step 1 would have been to find out omega by short circuiting the battery. And step 2 would have been, if I want to write the voltage of the capacitor as function of time, so I'll do that. I'll write some constant K1 plus constant K2 into sine omega t plus some constant K3. So this is a standard approach. So like indirect way of satisfying the circuit information to write the root of the equation. And then you understand omega is known to you by shorting the circuit. Now there are 3 variables, K1, K2 and K3. So basically I will keep on satisfying the initial condition. That is the initial charge term I'm going to satisfy, right? I am going to satisfy the current term. So I will eliminate 2 terms from there and 1 through any of the equation. I mean, instead of writing all 4 of them, I'll write 1 through any one of them, right? Because I know the voltage. So I can write that is LdI by dt here. And that voltage is Q by C. So you know that voltage is known, so Q is known. And then you differentiate, you know the current. So you know this current, you know this current. So the sum derivative is known, and then LdI by dt plus LdI by dt is E. So any one of them, like you can go from the basic to that solution, but indirectly also you can approach the problem and get the answer. So this is the fundamental way of looking into each and every aspect of the problem. All right. Yeah, Samarth, you want to say something?
Sir, can we take phi as pi by 2 plus pi by 2?
No. The reason is at t is equal to 0, from t is equal to 0, we need to look into the variation of current and charge both.
Yes, sir.
So the reason I have taken this as minus is because initial phase for the current should be decrementing from that point, right? I mean,
yes, sir.
This function is going to decrement that. So I need to consider that into picture. So not only I have optimally looking into the trigonometric solution, but physical behavior of the circuit also I'm observing. Because LdI by dt should be 0 now.
Yes, sir.
So that's what I have done.
Sir, can you explain the relation between capital Q and small q?
The relation between capital Q and small q?
Yes, sir.
What I've done here is, once I got this equation, I thought if I want to write the root, let me try to convert it into a SHM equation. The only thing was the mean position is at a different location. It was not at 0. But the nice thing is, if you take any variable q with a plus minus constant, its second derivative and the second derivative of q will remain the same. So I thought if I can redefine this variable as a new capital Q, the good thing will be it will get converted into a simple harmonic equation. So q minus c by 2 I wrote here. And then I say how to write the second derivative, but second derivative of small q and second derivative of capital Q is same from this equation. You understand? This is a constant. So
Okay,
this
sir,
and this are the same, right?
Okay, yes, sir. I got it. Thank you.
Yeah. Okay, let us take up the second problem for the day, where I will be using a bit of rotation in this problem along with the core concepts. The problem is somewhat like this, that there is a frictionless horizontal surface. This surface is frictionless. And you have a ring of mass m, radius r, gravity is present here. And now what we are trying to do is, there is a uniform magnetic field in the outward direction on the right hand side of this hypothetical plane, right? And somebody wants to push this ring into the magnetic field with a velocity v naught without providing any angular velocity. So the question is, if the periphery of this ring is having a uniform linear charge distribution, the question is, what should be that charge on the ring, so that if we flick the center of mass of the ring with a velocity v naught, and when this ring starts to enter the magnetic field, it starts a rotation, but the rolling is not pure. But as it is able to fully enter, completely enter, at that very moment, when it completely enter, it starts pure rolling. It starts pure rolling. If this condition is given, can we find out the charge on the ring? That is my question. So let us see how, and remember, in this question, there's assumption. You have to ignore the electromagnetic induction. It is given that ignore the electromagnetic induction, because when it will enter, the flux will change. And because of change of flux, the induced EMF, that has to be neglected. So only you have to consider the magnetic forces acting on the charged particles, these differential DQs, which are entering inside the magnetic field. Right? So it is given that ignore the electromagnetic induction because of the flux which is changing across the ring. Now if you look into the problem, let us say at a general, now what I'll do is, till it enters the magnetic field, nothing is going to happen. It will keep on moving with a constant speed v naught without any rotation. So it will move straight. Now let it enter. If it enters, now I'll try to draw the picture at a general t is equal to t. Now this is my ring. This is my ring. There's a portion of ring which has entered the magnetic field, right? At this t, I am having a velocity v. This is my surface. My center of mass is having a velocity v. My angular velocity is omega. Remember, v is not equal to r omega yet. This portion of my ring is inside the magnetic field. So definitely because of v and omega, everybody is feeling some force. So let me show the forces acting on this ring. There is a mg which is acting. There is a normal reaction which will act. Now the important thing, friction is not there. Now, all these charges which are present on the periphery of the ring, if you take any differential charge, it will have two velocities, right? So let me do one thing. Let me talk about a general guy here. If I go at theta and cut a d theta, I'm talking about this differential charge here. Let me talk about this dq. What is going to happen? And remember, the total distance that this guy has entered inside is x. And this boundary location was x is equal to 0. So I am sitting at this x. If you look into this dq and his friend, his mirror image, which is lying here, because by symmetry, I will cancel few terms. There is a guy, theta.
Sir,
Yeah.
will we not consider the magnetic force on the part which entered in the field?
Yeah, I'll consider the magnetic force only on the part which has entered the field. Yeah. If there is a charged particle and it is entering a magnetic field, there will be a force acting on the charged particle QV cross B. So all the charges which are inside the magnetic field, to take any dq charge, it will have two velocities, one because of its translation and one because of rotation. So center of mass is having a velocity v. This guy will have a velocity v. His counterpart will also have the velocity v. And because of rotation, he will have a tangential velocity, which is r omega. And I know that at this t is equal to t, we cannot be equal to r omega because yet pure rolling hasn't started. I have just given an initial velocity v naught, and at this stage there is some omega, but it is not v is equal to r omega because yet it is not balanced. Why it is not balanced? We'll see. How this omega came, we'll see, because some torque will be generated. So what will happen is this person and his counter guy, this guy will also have a velocity which is r omega, and now there will be forces because of both the components on both the people. Because of this velocity which is v forward, it will have a magnetic force which is q v cross b. Now because this magnetic field is outward, he will have a force acting on him which will act in the downward direction. We will write all these values, and symmetrically on this v, same dq will have the same force acting downwards. This red force which I have written there, differential force df downward, or df1 you can say, that is dq into velocity v into b. Velocity and magnetic field are at 90 degrees. Fine, good enough. Both are having the same line of action. And then if I talk about r omega, use a separate way. Symmetrically, if you look into this black r omega and cross it with magnetic field, you'll have a force towards the center again. Now this force which I have exhibited there like this or like this, these guys I'm going to call upon as df2. These people were df1, df1. They are df2, df2. What is the value of that df2? That df2 will come out as dq into velocity r omega multiplied by b. Now at this junction, if I look into the torque which is given by, if I look into all the forces which are prevalent on all the dqs, you understand that these people are not going to provide any torque about the center. mg is not providing torque. Normal reaction is also not giving any torque. So at this stage, if you look into the system, I'll write the total external torque which is given to this rigid ring about the center of mass. And that torque will be provided only by these vectors, these red vectors, df1s. And not at one point, we will have to observe torque from here till this point, and then we can do twice because on the lower segment also, the similar torque is present about the same point. So you can say this is twice off. I'm not bothered about the direction because I know that this is in the clockwise direction. So I'm just writing the magnitude in the clockwise direction. It is twice off. Now observe the force which is acting here and try to write the torque because of one of them. So if you take theta, d theta, you understand that there is a segment which is r d theta, and I'm observing lambda, that is the charge per unit length, as some constant on this complete ring. So the charge which is present there, dq, is lambda r d theta, that is dq, and dq I have multiplied by his velocity v, velocity of center of mass, into magnetic field B. And if you look into the lever arm, the moment arm, with respect to the center, it is r cos theta. It is r cos theta. And then just try to just integrate this at this stage from theta is equal to 0 to this point. Let's say this location is theta is equal to 0. And the last point here, entry point, that is theta is equal to some angle. You can take that angle as beta, alpha, whatever. Take it as beta. Alpha I will use for angular acceleration. So if I just write this from theta is equal to 0 to theta is equal to beta, I'll get some term which is lambda VB r square, VB r square, and you'll get this term cos theta, d theta, sin theta, 0 to beta, so sin beta. And at that moment, the total torque that I have calculated is on the upper half and then twice. So total is 2 lambda V B r square sin beta. That's what we are getting. Total torque at this T is equal to T Remember, this beta is a variable angle because the total distance that it has entered will keep on changing. So this beta angle will keep on changing. So with respect to a general T, I've written this expression at T is equal to T. At that location, I'm getting this much torque. And I'm saying that torque about the center for the ring is behaving as moment of inertia of this ring, which is mr square. So mr square into angular acceleration alpha at this instance. So if at T is equal to T, the ring is having an angular acceleration alpha about the center of mass, then mr square alpha should be equal to 2 lambda v b r square sine beta. Now, I know that angular.
Can you explain why the magnetic force is downwards?
Why the magnetic force is downward? Because I have taken two velocities for that particle, one v here and one v which is in this direction, r omega. So I have decomposed my velocity vector into two parts, and then I have done v1 cross b and then v2 cross b. And so I have the net magnetic force, which is a resultant of these two forces. And while I'm writing torque about the center, this force and this force cannot provide torque. You got the point? On a differential charge, which is on the periphery of the ring, we have two velocity vectors, one because of translation, one because of rotation. So instead of taking the net velocity and doing qv cross b, I have decomposed my velocity into two separate parts. Why I have done that? Because I wanted to take only those forces, those magnetic forces, which are able to provide torque about the center of mass at that point of time. And the magnetic force, which is acting on the r omega component, cannot provide torque about center of mass. So basically, I wrote the net torque about the center because of all the magnetic forces acting on the portion of the charge which is inside the magnetic field at that point of time. And because of this alpha, this angular acceleration alpha, I'll have a rate of change of angular velocity. So if I've got omega here, I can write this term as d omega by dt. So my interest is m r square d omega is coming out as 2 lambda v b r square sine beta multiplied by dt. Now it is a nice observation which is there in this problem. If you observe this equation keenly, there are results which you can easily write. How come? Let's understand that if this angle is given to us as beta, let's try to write the distance which has gone inside. So if I say that this complete angle here is beta, so I know that the value of x that we are writing is r minus r cos beta. This angle is beta. So it was r minus r cos beta. So then I thought, if this is my x, r minus r cos beta, let us try to differentiate this equation. Let's observe keenly. So dx by dt can be written as d by dt of these terms. So minus r will go out. Then d by dt of the cos beta term. So this becomes minus sine beta into d beta by dt term. And remember, beta is the angle through which it is inside. Like beta is this angle that I have taken here. And I'm getting this dx by dt as r sine beta d beta by dt. If you observe it, this term, and take constant separately, you will get a term which is v, which is in terms of v, and v is a variable actually. So this complete equation which we are observing here actually is talking about d omega of this system. And if you add all the possible d omegas, we can write the delta omega term. And we understand that initial omega was 0. So basically my interest is to take sigma of these terms. What I'm saying is, if I take sigma of these terms, my LHS becomes MR square into omega final. What about these terms which I have got in RHS? R sine beta is representing the dx by dt term through which it has entered. So let me substitute and tell you. R sine beta I'll replace by dx by dt with a d beta by dt term as such. So keep it as such. So if I would not have taken this, I would have got mr square d omega is equal to 2 lambda VBR. Take R sine beta. R sine beta you can write as dx by d beta, right? R sine beta can be written as dx by d beta. And simply you have got that dt term. That dt term. Now just try to observe. Are we looking into t of x coordinate while it is moving across? This d omega by dt will be taken care of. This we can write in terms of omega d beta by dt. I'll take it separately. I'll say this is mr square omega d omega, and I've got 2 lambda VBR dx. The d omega by dt term is separate. And that I've written into omega. Also, if you observe in one way, somebody can also think it like this, that v term is dx by dt term. At that point of time, he will eliminate dt. And then he will think in terms of area. I mean, I'll represent one more way. I mean, a person can say, sir, fine, let me look into this. This height you can observe. Just stay around with this question. I'll give you another perspective which will be more simpler for all of you to understand. This is R. This height is R sine beta, right? And that strip is V dt. So think of this as R sine beta V dt. Take a R separate. This is got R sine beta. R sine beta is this height. Take V dt. V dt is the differential distance that you will move forward. So that will be the differential strip area. So V dt, R sine beta, and make it 2 times also again. So I'm saying I'm getting mr square d omega as, now let me separate lambda r and b. Lambda r and b. And see what you are getting. 2 V dt R sine beta is actually the complete vertical chord area, strip area, dA, which will enter the field. If that is the case, why not I say mr square omega final is lambda rb, everything is constant, dA, all the strip area. So total area is pi r square. So I'm done with it, because direct perception tells me through time also I will reach the same destination, but it is getting more complicated. So I thought if you observe this way, I need not involve time at all. My interest is mr square omega final. Omega final is the velocity at the juncture when it is just entering. That is lambda rb into pi r square. Just observe this thing carefully. A much more easier way of looking into it, because that will directly give you omega final. Just again I'll explain. You got mr square into alpha is equal to this thing, then you wrote this thing as d omega by dt, dt is it. Now observe, at this instant, center of mass is having velocity v. So this endmost guy will move a v dt distance forward. So v dt I understand. R sine beta is this height, because this total angle was beta. And if I take 2r sine beta, the total height till the bottom point. So whatever is inside the magnetic field, the total chord length, the edge chord length is 2r sine beta, and v dt travels. So the differential area of the chord which enters inside the magnetic field in dt time is 2 v dt r sine beta. And if I separate that, I will only have a R, a lambda, and a B. So I took R lambda B and a differential area which is entering, and this is d omega. Now I will keep on writing such terms till it keeps on entering. So by the time it fully enters, the total change in omega is omega final, omega initial was 0. This is lambda RB. The total change in area. So initial entered area was 0. The final entered area is pi r square. So I got pi r square. I cancel r square here. I will get my omega final from here, which is lambda RB pi by m. Now, keep this point as such. First equation as such. You need not think in terms of time. That's not required. And second equation I'll write by conservation of energy. I will say if whatever, because gravity is acting, normal reaction is acting, they're not doing any work. Q V cross B is acting. In net, it cannot do any work. So we cannot have any change in kinetic energy. So second equation, simply, humbly, I can write that half m V naught square when it entered will be equal to the total kinetic energy when it just enters. And I can use the concept of ICOR at that point of time. So I can say it is half I about ICOR, mr square plus mr square. It is 2m r square omega final square. So r square into omega final square, and omega final is lambda r b pi by m the whole square. If you want to think in terms of lambda. Now this is the core equation which will yield you the result, because if you look into the problem, the only thing which was required, V naught was given to you. The required term was you need to find out the total charge on the ring. So let me just write this green equation even more prominently and yield the answer to you. Yeah. So just write that conservation energy equation carefully and give me the answer. What I'll do is I have got half m V naught square is half ICOR is 2 mr square into omega final the square. And omega final I have written as lambda b pi r divided by m. Just focus on this equation which can give you the answer. Here, lambda, the total charge that you have to write. So lambda you have to finally write as total charge divided by 2 pi r. One more step and then I'll leave this question. It is half m V naught square is equal to this cancels. So it is m r square. What I'm getting from the bracket is I'll have a q square b square. This term, this pi r will cancel out. And I'll have a 2. So I'll have 4 m square. Just calculate q from this and that will be the answer to the question. M V naught, R and B is all given to. If you look into the essence of the problem, what was the core concept in the problem? Energy conservation you are going to use. The second equation is actually the equation of angular impulse that I have used. What I have done at t is equal to t, I have written the angular impulse. Basically, I have written tau dt tau. If you observe carefully, I wrote it like torque, and then I wrote torque as I alpha, and alpha is d omega by dt. Basically, if you observe the d omega term, the angular impulse term is equal to change in angular momentum. The change in angular momentum of the system is the net angular impulse. And when you observe the net angular impulse, it is something which is proportional to the area which is entering inside the field. Because all these terms, V, R sine beta, dt, 2, this is the area of the differential strip which is entering. That is the nice observation. Then everything falls in place and you get your answer. All other parameters in the problem were given to you. So that is how you can approach this question. Yeah, Avinash, anything you want to say?
In the first approach, how did we get omega in our equations? Bottom.
In the first approach, that is d omega. How I have written d omega?
Bottom.
Yeah. Avinash, I have just written alpha as d omega by dt.
Sir,
And I have just taken
next
d.
equation of this,
The next one.
which is not shown here.
These
Omega,
equations.
how did that omega comes in?
Where? D beta by dt. I think you are talking about d beta by dt, na?
d
In
beta
this-
by dt is not omega, right, sir?
Even do I even need this equation? I'll explain it, but in this question, the complete observation will go in a different direction if we start writing this. I don't need it. I'll explain if you want me to, but I'm not going to yield solution through this because unnecessarily I don't want to involve time into the equation. Beautifully, v dt I can observe as my differential distance which is moving forward. So in as far as the solution of the question is concerned, you don't need it. One thing is clear to you, Avinash?
Yes.
Okay. Now, what are the terms that we can write? I have written mr square d omega. So this is something which was not required, but because I have written, I will just explain. That is not going to yield the solution because time is unnecessarily getting involved into the problem. So what I have done, I have written mr square d omega. What terms I have got here? 2 lambda v b r. All right. We got a sine beta term here and a dt term here. Then what I have done is, whatever dx, the particle has moved, dx by dt, x from the equation I had written earlier. So that was r, if you observe, what is the x? That was r minus r cos beta. So I've written dx by dt, everything came out. d beta by dt term I got. So I don't think there is any problem till this step. This is fine.
Yes, sir.
Then I said that at general point of time, the angle which is inserted inside the magnetic field, if I say at general position, this angle is beta. Think of this system like a disk. Let me just explain it more beautifully. Think of it like a disk and draw a line on the disk, which is radial. Now, this rigid body can do any combined motion, but the property says that for any possible motion, which can be a combination of translation and rotation, the angle that all the rods will rotate, that will be the same. And if you look at this level is not going to change. The central level is not going to change. The center of mass is still moving on the horizontal line. So if I knew the omega, I've just taken rate of change of omega, the rate of change of angle as angular velocity for any radial line. You can say I can go into the frame of reference of center of mass and then I have written that. Because it is purely rotation. Both the endpoints of that rod are moving with the same velocity. So that effect is compensated. With respect to this point, only rotation will come into picture. And the total angle that is inside here was beta. So I wrote that d beta by dt. So that is the equation which I have written, but definitely not required. What is more interesting in this question is this observation. Samarth, I'll come to you. Is this observation. This equation itself is beautifully coming out in terms of area. So why should I involve time into it? That's what I have said. Any problem, the same equation you are pursuing further. So you basically, I'm saying integral tau dt is equal to change in angular momentum. Somebody will say integral tau d theta is change in rotational kinetic energy. So I think you understand that both the things that we are writing are kind of same.
Yes, sir.
So that's what I said. If somebody can observe this step here, he's done with the problem. I mean, there's no, why should we even lengthen the problem into another step?
Yes,
That
sir.
is fine.
Got it.
Yeah, I think you will get your result from it. Okay, so let us, because ultimately if we start integrating all the terms now, we'll get into the, what basically we will get is that the energy will get conserved. So the kinetic energy conservation, which I have done directly because I knew that the work done by all the forces is zero. If I start integrating and go to that point, we'll get the same term. So I think we can directly write that. Okay, let me take a few more ideas. Now, let me take a concept of transformation field here. Let's see how the problem shapes up. Again, we can solve this problem by multiple methods. At least 3 of them are there. But one transformation can make this problem simpler, and that's what I wanted to discuss, the transformation field here in this problem. Just observe it carefully what is happening here. There is a frictionless incline which is at an angle of theta, and there's a particle which is left from rest. it slips a distance L on the incline, leaves the incline, and then follows some general curve, which he is saying is a cycloidal trajectory. We can even justify why he's saying that the trajectory is cycloidal. Because this is very standard problem where you have one force which is downward, which is because of gravity, which is constant, and another QV cross B because of velocities of this particle at different locations. Now, the question is, if on this trajectory, the maximum vertical displacement of the particle comes out to be h given. So can we find out the distance? So it is more important to present this problem in a proper way. Let me say, given parameters are theta, g, and h, and you have to find out the value of L. What else is given? Theta ke saath, they have given you B, the magnetic field. Yeah, that's suffice. So theta, G, H, B. He has not given anything about the charge and mass. So those terms we need to eliminate. Let's see what is going to happen to this particle starting from. Remember one more thing. The location from where we have started and the highest point of this cycloidal trajectory, they cannot be in the same level. You understand that magnetic forces cannot do any work. And when he will be at the highest point, he will have some kinetic energy. So definitely his potential energy should be less. So from the point from where he started and this highest point should be such that this is below that point. So definitely this point will be above this point. So this is something we should keep in mind. Okay. Now let's come to the question. The question here is, let me start the basic solution for that. Just a moment. Thickness. Fine. So what are the forces when he started? Initial motion is very simple. He started from rest. Magnetic forces can't do any work. So when he leaves this point, he will have some velocity u. So let me write my first equation. U will be equal to root of 2g sine theta multiplied by L. And I also know that if normal reaction here becomes 0, N becomes 0 here. So you can write, and this B is in the cross direction that is given to you. This B was in the cross direction. So basically, mg cos theta at that point has balanced QUB. So that is my second equation, which I can write here, because of which normal reaction became equal to 0. U is this, the second term. Now comes the interesting part. Now with this U, it comes in the magnetic field, uniform magnetic field, and gravity is also active. So his path, I think most of us know this is a very standard problem, that this guy will pull it, the second guy will try to rotate it, and we can prove that this path becomes cycloidal. Very standard problem of Irodov as well as H.C. Verma, where instead of mg, they have taken QE force, and they show that this path becomes cycloid. That's fine. Now here we are not interested in that, but we understand one thing, that this cycloidal trajectory can be revisited, again observe as something which is a combination of a circle and a uniform linear motion, and that uniform linear motion can be perceived as something which is going forward with a uniform velocity. And that uniform velocity, if I take as some v such that QV cross B, the transformed field, which is V cross B, I mean this transformed field V cross B, which can be called upon as E transformed, ET or E, whatever you want to say, that will serve the purpose of, this will become QE now, QE transform, and that will, if that balances mg everywhere, then the problem becomes very simple for me. Because in that situation, this E transform become VB, and that is sin 90 term. So basically what we are trying to say is, if I start going into a frame which is moving rightwards, inertial frame, with the velocity of V, which is uniform, then I get a transformed electric field here, which is V cross B, and that uniform transformed electric field balances this uniform force mg. So in that situation, what happens is QVB becomes equal to mg, and not only that, from that frame, if I start observing my particle, now my particle at t is equal to 0, from the location where it is leaving the tangent, the incline, he will have a u and he will have some v backward, right? So what I can do is I can take this angle as theta and this angle here is theta, right? Now I will try to find out the net velocity that I'll have because of these two components. And now from this field, the transformed electric field is indirectly balancing. It is balancing gravity. It is behaving like anti-gravity. So I don't have this gravitational force. So now my path, instead of becoming a cycloid, becomes a uniform circular motion. And if that becomes a uniform circular motion, if the cycloid has a height of h, then in that uniform circular motion, my twice of radius will be equal to h. And radius in that frame will become mv upon qb. And you can say this is v net speed upon charge into magnetic field. And now what is that v net? See, what I have to do, I have to take the resultant of these two forces. So I'll take the components. I'll take v cos theta here. I'll take v sin theta here. And then I'll remove this v vector and I'll take the resultant of these three. But interesting thing is that v cos theta is balancing this u, because v is coming out as mg upon qb. So mg upon qb cos theta is u. So basically this v cos theta and u cancels, and this v sin theta also becomes my v net. And now this velocity component will be moving in a circle because of the magnetic field. So that portion of cycloidal motion becomes very simple. And I know that the diameter here is h. So instead of writing v net, I should replace it by v sin theta now. Now I have these four basic equations. One I have written by energy. Secondly, I have made normal reaction 0 here. Third, I have taken the transformed electric field, ET term, which is balancing mg. And fourth, I have written R is equal to mv upon q. Now from these four equations, try to eliminate q upon m term as such and try to find out L in terms of h and theta. In fact, if you solve carefully, B, G, all these terms are also getting eliminated. So let us try to write that expression carefully, what we are getting. So finally, now whatever I am doing is just calculation on the basis of these equations.
Can you once explain v cos theta equal to u once again?
Yeah, you got the value of u
How
from
did
here?
you prove v cos theta?
How
Yeah,
it is
yeah.
equal?
How?
You got this. So look into the second equation carefully. I got u is equal to mg upon qb into cos theta. But mg upon qb I have already written as v. So u was equal to v cos theta. So this will now cancel out this component and it becomes only v sin theta.
Yes, sir.
And now just you have to square these terms and compensate. So let's see what we are getting here. We are getting 2mv upon qb into sin theta term, right? And that is equal to h. Now try to eliminate these terms and give me h is something which is fine. I can keep. Try to convert all these terms in terms of L. Let's see what you are getting. Some square terms you will have. Theta you can always keep because that is known to us. So we have to just substitute the value of v. So mv upon qb. And that you can replace in terms of u. Because indirectly from first and so just focus on the second. By first and second, what you are getting is mg cos theta is equal to qbu, and u term is root of 2gl sin theta. So what we were getting from here, just square the equation, you were getting m square g square cos square theta is q square b square into 2gl sin theta. And v I can directly write as mg upon qb. So I think you get this point. I'll do 2m upon qb. You're writing h, 2m upon qb. V I am writing as mg upon qb again into sin theta. So now what I am getting here is it is 2 mg upon qb the whole square into sin theta. Now this is 2 sin theta into. Now mg upon qb I will find out from here. So mg upon qb the whole square is basically 2gl sine theta upon cos square theta. Just substitute this equation here. So 2 sine theta into 2gl sine theta upon cos square theta. Cos square theta. So now finally, what we are getting. So I should say I'm getting h as 4gl sine square theta upon this 4gl sine square theta upon cos square theta. And I think this will be your answer term because theta g, and out of h and l, one term was given to you and second was required. So I think what is given and required, L you have to sort out what is the value of L. So I think you'll get L as h upon 4g. I'm having a cot square theta. You will definitely get your result. So primarily, if you can write these 4 equations carefully, and if you look into the net velocity, and then by circular motion, if you put down the diameter as h from the frame where you are moving with a constant velocity v rightwards, your motion becomes very simple in the transformed field. Then everything falls in. So these 4 equations were important, right?
Dimensionally, answer is not correct.
Check the calculations. I mean, if you have, are these 4 equations clear to you? I will check it again then.
Okay, sir.
Just check. U is the root of 2gh, 2gl sine theta, that's fine. Mg cos theta is qub, that's fine. Qvb should be equal to mg, that is fine. Mv upon qb, so 2m, v is v sine theta upon qb, that should be h. So there is no issue in these 4 equations. Now let me check, are all the terms written? 2m upon qb, v sine theta written as h, that's fine. So 2m upon qb, then v. V was mg upon qb into sine theta, there is no issue in that. So twice of mg upon qb the whole square into sine theta, this is fine. Now let me see here what I have done. I have taken mg cos theta as qb into u, and u was root of 2g sine theta into l. Up to this point, no issue. So I just squared it up. M square g square cos square theta is q square b square into 2gl sine theta. Perfect. So mg upon qb the whole square came out to be 2gl sine theta upon cos square. This much is perfectly fine. So I've substituted here. So 2 mg upon qb the whole square sine theta is 2 sine theta. Mg upon qb the whole square was 2gl sine theta upon cos square. That was fine. Absolutely right. No issues. So h, 4gl, all these terms, and you'll get your answer. That 4, 2gl, I think you understand when you will write everything in a dimensional manner, there will be constants here which are involved. You understand this point now, Avinash?
Understood, sir.
Yeah, so dimensionally it will go. Okay. Now let me take one problem in a different context and let's see how you solve this. This is a very conventional problem. And it is based on magnetic pressure concept also. That's why I'm taking this. The problem says that I have a solid cylinder which has got a current density of J. And this current density is uniformly spread on that infinite solid cylinder. So the question was, can we find out the force of interaction between the 2 halves of the cylinder? I'll explain the question first. If this is my infinite solid cylinder, right? And there's a current density J in any direction, so take it in the cross direction. Now the concern is the half cylinder, the upper half, what force does it exert on the lower half? And what is the data which is given to me? Now J is given, like R is given. So obviously he's expecting me to write my answer in terms of mu naught J and R. So these are my given parameters. And I need to report the expression for the force of interaction per unit length. So I'll just substitute that term finally. Now, the idea to observe this problem is, you think of, what I should say, I'm thinking like this. I'm observing the lower half of this solid cylinder. I want to write the force on the lower half. So what I've done is, I've taken a hollow half cylinder of radius small r. So maybe take a radius of x and cut a dx here and just cut this lower hollow half cylinder having thickness dx and radius of x. So go to a x and cut this element dx here. Then just try to write the force on this part. You know, J is given to you. So what I am doing here is, let me write it this way. On this, although we can directly also report it also, but let me try to explain it to you. What I've done is, on this half cylinder, I've gone to a theta location. I've cut a differential element here, which is ds, this length, which is rd theta, whatever you want to say. This thickness is dx for me. I want to just write the pressure on this part. I mean, the force which is acting there. So if we do by the basics, indirectly, I'm looking into a rod which is having a current of J dx ds. So ds dx into J is the current. Take that rod to have some length, which is 1 or whatever, like 1. Now, if there is a magnetic field, if the current throughout is in the cross direction, it is J, then there is a magnetic field which is mu naught into JR by 2. So basically J x by 2. This is my magnetic field. This is my current in that wire. Now, length I am taking as 1. So current I, length L, this is magnetic field B. So I've taken ILB and look into the force. If current is inward and magnetic field is clockwise, so if you take this force, this will act towards the axis of the cylinder like this. This force will act like this. And the good thing is, if you look into the symmetry of the problem, on the complete half cylinder of length 1 meter, you will observe these kind of forces. Now, if I look into my symmetrical friend here, he will also have the same force. So basically what I'm trying to do is, if this much is there on this guy, I want to write the net. So I will take the net to be upward, and then I can use the concept of pressure into projection area. And we understand that the projection area, if you look into the net force on this half cylinder, I say that net force will be vertically upwards. Just focus on that half cylinder and think of these forces like pressures. So this net should be equal to that pressure term. I'll write that pressure into area. If you take the projection area, what should be the projection area? It should be this 2x and length is 1. So basically 2x into 1 is the projection area. And how come will you write the pressure? So this is the force that you have written on that patch. And if you take the pressure, so length is 1. So just divide it by 1 into ds, you will get your pressure. And then all like vertical. So answer to the question should be, on the lower half, there is a force which is acting upwards, and that value should be integral or summation of this term. What is that? So ds 1, this will all cancel. So it is mu naught J square by 2 x dx, and then just multiply by twice of x. And then say that I'll cover up x is equal to 0 to x is equal to r. This is all taken care of. It is mu naught J square, and it is x square dx, x cubed by 3. So r cubed by 3, that should be the correct answer. Someone like, I need not integrate it again, because once I understood that there's a pressure everywhere, and for that strip that I've taken, when I said that I'm taking ds dx over a length, that area was, that differential area was 1 ds, then everything was fit and fine. Everywhere the same pattern is there. So uniform pressure, and the net force on that lower half hollow cylinder is this much. I integrated, I got this. So I think it is straightforward to all of you. Great. Let me take one problem which is more often put up in terms of, let me take this problem on capacitance. A very nice objective problem. Just let me take this simple problem and then go to a more complicated version. Here they have given you two capacitors, C and 2C, consisting of plates of identical dimensions. This is the initial state. And what this guy is doing, he's bringing in the plates of this capacitor inside this system, and then he's flipping the polarity also. And his question is, while I'm doing this, what will my battery do? What amount of charge will be supplied by the battery along with the work? Will the battery do positive work on the system or not? That is the question. So let's see how you observe this. Like, all of you can try also yourself, and I'll also try to explain this. In the initial state, what has happened? If the capacitances are C and 2C, now this distance seems to be high, so his capacitance is low. So it seems that charge here is 0, CV, minus CV, 0. And it seems that charge here is 0, 0, 2 CV, and minus 2. I'm just trying to explain charges everything. So that was the initial state. And let me mention that their numbers like plate A, B, C, and D. Again, I have got plate A, B, C, and D. Now let's see what is happening here in this state. Now I'm putting a few charges. Just observe. This is the most important step of this solution. If we understand it, we are done. Here in this state, I say the charge on this outer surface is 0. And remember one thing, they have categorically given that the plates are inserted symmetrically, completely inserted and kept in a symmetric position. So we understand that if I take this distance as D, I was quite clear that this distance is 2D because areas were the same and capacitance was half, so distance is twice. And here, if this distance is D, the total was 2D. So basically, this is D by 2 and this is D by 2 because he has said that I have kept it in symmetric position. So these are few things I can analyze before solving the problem. Now what can I do? So I know that because the net charge the battery is going to supply anyway is 0. So outermost surfaces cannot have any charge. Now comes the point that how charges are distributed. So let's observe the inner guys, the B and the C ones. So you see that this plate is negatively charged, this positively charged with the same voltage V, and this capacitance is still 2C. So I say here I will have a plus 2CV inner surface, and here I will have a minus 2C. This much is fine. Conceptually, we understand that the field between these two plates is only because of the charges on the inner surfaces of the subsidiary plates. Other plates cannot generate field in this segment. Their contribution in field will be 0. What else I know here? I can presume some charges. I can say this is some X, this is minus X, something, I don't know. I'll find out. And similarly, I've got some Y and some minus Y here. Now, what is the relation that I can write? So I thought from top to bottom, the net potential difference, like upper plate is at positive potential. And this guy, the lowest one is at V. So top to bottom V. So V, I can write it as ED term. So simply what I have done is, if you look into X upon A epsilon naught into D by 2, these A epsilon naughts and all, they will cancel in terms of C. Don't worry about that. I'll remove them. Or directly I can use C also. Like X by C, X by C. So let me do one thing. If you are comfortable with that, we can directly write that way also. So I can write charge upon capacitance and I can add those terms directly. So I can say for this D by 2, it is X upon C and it is A epsilon naught by D by 2. Right? So it will become 4C. Check. I've taken A epsilon naught by D as 2C. And A epsilon naught by 2D as C. So I have taken A epsilon naught by D by 2 now. So that will be 4C. So plus. Now the second guy is giving me minus 2CV upon the capacitance. And for D here, again, I've got a capacitance of 2C. for D. And then finally, the third term is Y. And here again, I'll have a 4C term. So it is nice because you want everything in terms of C into V. So I've just written a potential drop from top to bottom and I've equated it with V. Top plate is still connected with the positive half and negative is connected with the bottom one. Inner ones, I've already taken the charges appropriately. So I got one equation in terms of X, Y, and all the parameters. So what is that we are getting? It's 2C, 2C will cancel out, right? This will become 2V here. And you are getting some terms like X plus Y upon 4C. So I'm getting X plus Y as 8CV. Now let me see what I want to report, what is required in this question. He has clearly said that what is the amount of charge which is delivered by the battery. So just focus on the positive plate. Positive plate of the battery is connected in the final state to this guy and to this guy, the A and the C ones. So I am saying charge supplied by my battery, by the battery, should be equal to the change in the charges of these two plates. So C and A is having a final charge of total 2CV plus Y plus X, the total on all the surfaces of CA, minus. Initially C and A, so C was having minus 2CV and A was having a CV. So basically what I got here is, if you observe carefully, I've got a 2CV term, I've got a X plus Y term, and this is here what I've got is CV minus 2CV, right? So minus CV, so plus CV term here. Now check.
Sir,
Yeah.
in second case, B and C are exchanged, sir. Figure 2.
In figure 2, what I have, the name
It
has
must
been
be
changed.
ACBD, no, sir.
Now this plate B is inserted at the top, C is inserted here. He has just flipped the polarity. Na? C is connected to the upper side and B is connected to the lower side. That's what he has done. Just check.
Only you written letters wrong, sir. All are correct.
Everything you are saying, I have to change this by C and B. That's what you are saying. Let me read it again. Like I have analyzed everything. What you people have said is, let me read. You are saying now the capacitor in the volume is completely inserted into the larger capacitor, kept in a symmetric position, and then connection polarities of the plates are reversed. So what I've done is, I've taken B inside, I've taken C inside. B is now connected to the lower side. This connection is lost. He has connected it to the lower side, and C is connected to the upper side. That's what he has done. Just
Sir,
check.
or we can also say that B has been brought down and C has been taken up.
I mean, like for me, I just observed the question like this only. He said, I will just insert this inside. So I just took it inside. And then I have just flipped the connection. So he said, okay, B will be connected there and C will be connected here. Because he has not written that I'm flipping. We could have done that way also. Question, it just depends how he wants to define the problem.
If we remove connection, we cannot say charges. We cannot subtract charges to find charge supplied.
Okay.
So that way is the only way we can do.
From the, you are saying you want to bring this plate on the lower side and this plate on the upper side. You don't want to disconnect it and then reconnect. That's what you are saying, I suppose.
Yes, sir.
Tell me one thing. If initially I've charged the capacitors and I remove the battery here itself, so there won't be any changes in the total charges. Now, the second step, I can do these two things simultaneously, bringing them inside along with connection to a new battery. These two steps can be done together.
Yes, sir.
And that will yield them a final state, because like potential indirectly, I can say that these are my initial states. I have charged them up. Now I will take, forget about battery. I'll take DC charged, AD charged. Now I'm inserting them inside along with these polarities maintained. So some turbulence will be there in charges, but they will stabilize in a final state. That's what I'm trying to do here.
Yes, sir.
Check. So accordingly, if you want, we can form that problem also. I don't have any hitch with that. But in this situation, I've written everything. Just check.
Sir, initially charge supplied by battery is 3 CV, no, sir.
Okay. The battery is connected to B and A. Yeah, the positive has given a 3 CV total. And finally,
Yes, sir,
so that you can change. That you can change.
now we will get the answer.
Yeah, you're right. No issues with that. This step I understand. This is fine. Here you should write, because the positive plate is connected to people who are having a total charge of 3 CV. That is perfectly fine. So I'll have X plus Y, which is 8 CV, and a minus CV, so 7 CV. So battery will supply 7 CV and it delivers energy. So A, B, C are wrong. You'll get. So that is perfectly fine. So that's what I was trying to explain. Just for a moment, observe. The positive plate was connected to this, and they were having a total charge of 3 CV. In the final state, this positive is connected to this, and they're having a total charge of 2 CV plus Y plus X. So basically, the deficit is what the battery has supplied, and that comes out to be 7 CV, because battery is supplying charge, so it is delivering energy. So charge flown through the battery is not delivering. I was trying to just explain this idea. I think all of you are clear about this combination. So I think you got the idea, and only I changed the charge. And I did not look into that. That was the idea. Actually, I tried to flip it, but basically in the diagram, I haven't. So only I have to look into the change. And positive guy was already had supplied this much. Finally, this is a situation. So extra he would have supplied to these two people. Yeah, just try to think about this problem. Then I'll go back to capacitor. I'll try to take one more similar problem. This is a nice idea. In this problem, the question is somewhat like this, that you have to find electric field everywhere on a plane, which is containing the borders of two parallel half planes extending in the opposite direction. And the distance between the half planes is D, and they have uniform. It's nicely written. It's like if you take a sheet in such a way that there is an end line of that plane. So it's like a half sheet type of stuff. So this end is defined, and on the other side, it is extending up to infinity, right? And then how come the other one? So this is, you have to find electric field everywhere on a plane which is containing borders. So this line inward is the border, and the other border is such that both the borders lie on this plane. So basically is saying that this is the infinite sheet for us, having this line as my border, and this is another semi-infinite kind of sheet up to infinity, up to minus infinity, and these two edges are like borders, and this is the plane which is crossing those two borders, and the plane angle between the plane and the half plane. Half planes are these two planes. This angle is given as theta. And he has said that the distance between the two planes, so generally they provide the shortest distance, so perpendicular. So if this perpendicular distance is D, you have to find out electric field everywhere on the plane. The question is somewhat like this. So very like conceptually, you can report this problem. Just think, if I start calculate, let me take a point P here. Let me try to write the field at this point. These two guys are having sigma. Now, when you will try to find field here, I can make a statement. I am saying hypothetically think that instead of having this plane here, if I shift this plane to this location, if instead of having this plane, I would have got this hypothetical plane here. If I justify that this colored plane, which I've drawn here, and this purple plane, which is here, are having the same fields at this point, then I can do this transformation. And if I can bring this here, then it is a simple complete sheet. And my answer is sigma upon 2 epsilon naught vertically upwards. So the logic is only this much. Now, how to define that? Now I'm saying, if this hypothetical guy was having some sigma, what will happen? If I cut an element here, I like to draw two lines. Now observe that in 3D, this charge element that you have drawn is actually a thin linear infinite charge element. And this is also an infinitely charged element. And I want to just justify that the field because of this guy here and the field because of this guy here is same. If that is right, then this complete guy can be shifted here and then your answer is true. So only small calculation I have to exhibit. Now you can prove it by simple geometry. How to write the field? Like if I go to this angle, if I take this angle with the vertical as some alpha and cut a d alpha here, just let me observe how to write this term. So let me take this point, let me go to this x, let me take this dx. Tell me, because of this lambda, what is the field that you will be writing here? It is 2k lambda upon r, lambda upon 2 pi epsilon naught r. And if this distance that I have taken is r, because of this, I'll have 2k upon r. I just want to write lambda. Now how to write lambda? Lambda can be written as sigma that I have got into dx, so charge per unit area into this, and length you can take as 1. Because I have to write charge per unit length. So basically I've taken the depth as 1. So that area became dx into 1. So that charge became sigma dx, and that is basically lambda. So 2k lambda upon r. So now this 2k sigma is a constant. So basically I got 2k sigma dx upon r. Now just think, you got this dx upon r, and if for the counter element, I go here and I take this guy as my x prime, this alpha d alpha is same, and take this as my r prime, and this is my dx prime, I'm making a statement. I say you got dx upon r, and if you will start writing because of this, you'll get dx prime upon r prime. The other contribution will be 2k sigma dx prime upon r prime. Now check. Is it correct that dx upon r is a dx prime upon r prime? If that is correct, then this transformation is correct. And then the answer is sigma upon 2 epsilon. So by similarity, you can directly say that. You understand this when I'll write the ratios like x upon r or dx upon r term, right? And then I will write x prime upon r prime or dx prime upon r prime term. I'll get the same term. If you want, I can write the simple equations also to derive it, but I don't think it is required. Directly by geometry, you can say that. I could have used the concept of solid angle, but not in the correct sense because this is having a linear symmetry. So maybe I have to distribute into in 2D step. I cannot purely call it as solid angle. So directly I'm not using that term solid angle because it is not a point charge, it is a line charge. So basically these are 2D angles. So once I justify this, this can be shifted and then you can directly say the net field is sigma upon 2 epsilon. Just take some time and check, take your time. What is that term that you are getting? Check that and use the similarity of triangle and tell me what is the value you are writing, or you can directly observe it.
Sir, how to say the upper left one and upper right one contribute the same amount?
Upper left, upper left I have kept as such. The lower right I have shifted to this upper position.
Okay,
this
sir,
is
got it, sir.
Got it, huh? So this is the hypothetical surface.
Yes, sir.
So once I do that, the complete purple guy will be in the same plane and my field will be sigma upon 2 epsilon naught vertically upwards. That is my answer.
Yes,
and
sir.
similarly, when you will go down here, you will try to write field here, somewhere here. So I'll say this guy keep as such. Now the contribution of this guy, I'll draw a hypothetical guy here. Then I'll say this guy will shift from here to here. So this complete guy and this complete guy, then the answer will be sigma upon 2 epsilon naught downward, perpendicularly downwards, perpendicularly upwards. Similarly, when you will take a point here, somewhere here, what I'm going to do, I'll cut an element here. I'll take a field because of this guy and his vertically opposite I'll take here and I'll justify this contribution and this contribution will cancel. So field everywhere here will be 0. Everywhere here, 0. Everywhere here, vertically upward sigma by 2 epsilon naught. Everywhere here, vertically downward sigma upon 2 epsilon naught. Logic in all the three cases is the same. So if you can justify this, symmetrically you can justify all the 3 cases. So I'll
Yes,
now
sir, got it, sir.
got the point now. So then it is straightforward and you'll get your answer. So spend some time, think about these things and try to go through these ideas. I'll try to take up more such problems in the next class. And I'm deliberately, in this class, you must have observed, I'm not taking very lengthy problems here, because I think towards the end, that is while we are appearing, it is better to take up problems which are not very lengthy, but the concepts are quite ticklish. That is what you are going to get more. So yourself also, while you are revising your concepts in the last 7-8 days, do as many problems as possible, but not very lengthy ones, not the real Olympiad problems. So maybe this is the time to, take ticklish problems, but not the lengthy ones. Okay, fine. Good night to all of you, and I'll see you again in the next class. Bye-bye. Take care.